Hello, everyone, and welcome to Haworth's webinar, Architectural Acoustics, Designing for Workplace Performance. I'm David Milanowski, and I'm a member of Haworth's corporate marketing team, and I have the pleasure of introducing today's presenters, Jim Goodchild, Principal Research Consultant for Haworth, and Lori D'Amico, one of Haworth's Senior Architectural Product Specialists. Thank you both for leading us through this knowledge webinar on acoustics, speech privacy in the workplace. So without further ado, Lori, let's get started.
All right, thank you, David. So today we have a handful of topics we're going to cover. We want to talk about the state of our workplaces, Haworth's approach to space types. We're going to refer to speech privacy, intelligibility, and the difference between them. We're going to talk about some design tools, how to use them, as well as Haworth's architectural products. So we're going to address many of the common questions regarding speech privacy we hear from designers and customers, and we will dive into that. But beforehand, let's review some of the research that supports our approach. Jim?
Thanks, Lori. In 2023, Gensler published a really interesting update in their long-running series of workplace surveys. This is the first conducted since people started returning to the office after the global pandemic, and the results are compelling. In all markets around the world, Gensler found that people want to return to the office, and the primary reasons for doing so should not be surprising. It's the things that are hard to do elsewhere: focus work, having in-person meetings with colleagues or with customers, all activities that are essential to business and all things that bring with them acoustic performance expectations. But having had a taste of hybrid work, people appreciate choice in where to work, even more than they did before, and they don't want to give it up. So that means that the workplace, which is still underperforming in many respects, just as it was before the pandemic, must change to become the destination of choice. Acoustic performance must be addressed. Now, we've known for a long time that people generally find the open plan office unsatisfactory for noise and privacy. In one notable study based on data compiled by the Center for the Built Environment at UC Berkeley, sound privacy and noise in general yielded 2 of the 3 lowest scores of all the indoor environment categories. Privacy was the worst overall, reported by over 50% of open plan workers and about 18% of those in closed rooms to be a problem. And Haworth's own research informs why it's so detrimental to have an underperforming acoustic workplace when it comes to focus work. Visual and auditory distractions interrupt the information processing functions of our brains, taking resources away from the focused task at hand. And the impact on productivity is greatest for those tasks requiring the most intensive concentration, up to 23% in Haworth's findings. Haworth is not the only entity to report this key relationship. In a meta-analysis published in 2020 by Hapakangas, the reduction in performance associated with the distracting effect of irrelevant speech has again been documented in terms, in this case, by the Speech Transmission Index, or STI, with a performance loss of up to 16%, starting with an STI value as low as 0.15. But it may be even more serious than that. In 2021, in a study from Finland, they were able to show a correlation between irrelevant speech and stress levels, suggesting that prolonged exposure to such conditions may lead to adverse health effects. And this would seem to reinforce the findings of a couple of earlier studies reporting higher stress-related absenteeism in noisy offices, or that there was a greater risk of disability retirement in open plan work offices. So the stakes are actually quite substantial. And whether people returning to the workplace understand it to this degree, it still needs to be addressed. Over to you, Lori.
So We understand from the research and from our own experiences that there's a greater need for privacy and also an equal need for both focus and collaboration. So I want to take a few minutes to talk about programming and illustrate how we as designers can plan for different acoustic needs within various space types. So we are always focused on creating a functional environment by providing adequate space, proper furnishings, and lighting. Acoustics is just one more element that we need to take into consideration to create really well-designed spaces. So we're going to walk through a couple floor plate here. And what you're going to see is a leading investment firm that was relocating to a new HQ building. One of their project goals was attracting and retaining talent, future-proof modular design that supports reconfigurability and change management, as well as a heavy emphasis on maximizing acoustics. These are drivers for a lot of the customers that we're seeing. And so this is why it's important. When you look at a floor plan, you're going to see a lot of different ways that sound can impact a space. And some of those causes of disruption are through the circulation paths and open space plans. And what we want to do is provide various levels of acoustic privacy as well as choice in the different types of work zones. So how did they do that? They created many different space types to support both individual and group work. While a large area of the floor plan was allocated to open workstations, they also provided a balanced amount of square footage for collaboration spaces, focus rooms, and restoration. And because they knew their needs would change over time, they utilized modular interior components, in this case, pods, access flooring, demountable partitions, to leverage their ability to respond to the changing nature of their different teams. So creating spaces for choice with the added ability to be flexible in the future is a real game changer. We've recently redesigned a space here at our own HQ in Holland, Michigan, that I'm going to walk you through. So in a nod to the research we've done at our newest area here at Haworth, we've created a neighborhood hub for members on our second floor. This new neighborhood offers an abundance of choice with focus rooms, small meeting spaces, as well as refresh spaces and teleconferencing areas. So, Jim, I'm going to send it back to you to talk a little bit about speech intelligibility and privacy.
Sure. So when we talk about speech intelligibility and privacy, we're describing something that we encounter every day. But to level set, imagine the circumstance that you're riding on public transit and you can overhear a conversation. This happened to me a little while ago when I could clearly overhear a conversation, a very animated conversation that was being had by a couple of other passengers standing in front of me. They were quite enthusiastic about what they were talking about. They were very animated. They were very loud. I could clearly hear every word that they were saying. But because they were speaking in what I think was Arabic, I couldn't understand what they were saying. And that was because I don't speak the language. So the fact that their conversation was clearly audible meant that I could hear it, but I couldn't understand it because their speech to me was not intelligible. So simply, audibility and intelligibility are not the same thing. Just because we can hear a conversation doesn't mean we can understand it. And similarly, if we can understand that intelligibility is different from the audibility, we can start to manage privacy. So when we talk about intelligibility, what we're really talking about is speech that is a desirable sound. That's when a listener can both hear and understand the speech sounds that are arriving at the listener's ear. Privacy, then, is when you remove one of those things. Now, of course, privacy might mean that you just can't hear it, but privacy also exists when a listener cannot understand the speech sounds that they overhear. And again, that is also measured at the listener's ear. So in the case of my fellow riders on transit, they could have a private conversation because the people around them couldn't understand what was being said.
So now that we understand the different space types and speech intelligibility versus privacy, let's identify the performance properties that can be influenced by design to optimize the intended use and functionality of the different workspaces. So, as you can see here, there's three different paths. We have a talker, the path of the sound, and the listener. And the factors that affect intelligibility or privacy are experienced at the listener's ear. So, and some of these factors we can control through the design, and some of them we have no control over. So you can see here that we can't necessarily control the speaker's voice level, the frequency of the content, or the language. But we do have the ability to control the distance or the construction in the path of that sound, as well as absorption and diffusion. From the listener's perspective, we also cannot control their ability to hear or their attentiveness, but we can control background sound and the visual information. And this is also known as the ABCs of acoustic design. We can absorb, block, and cover to control sound. And Jim's going to talk a little bit about absorption.
I am. So absorption describes the broad category of materials which simply do not reflect all the sound that is incident on their surface. This property is quite useful for reducing sound levels in a room, or reducing echoes, or preventing sound from propagating through a large space by managing the ability of the sound to reflect or not reflect off surfaces, such as a ceiling or a wall. In open plan spaces, absorption of a ceiling is critical to trying to control the propagation of sound through an open plan workplace. And it's essential for all these reasons. But in closed rooms, absorption also enhances intelligibility, both for listeners in the room, as well as for listeners who might be on the other end of a conference call or a video conference, such as we're having right now. If you run across the acoustic measurement called NRC, or noise reduction coefficient, that's a measure of the absorption of a material. It's measured on a scale from 0 to 1, roughly representing the amount of sound that is absorbed or not reflected by the material. If the rating is 0, that means all of the sound is reflected, none is absorbed. And if the rating is 1, that roughly means that all of the sound is absorbed and none is reflected. And here are some examples of the reverberation time, which is what we're trying to control with absorption in a space. A gymnasium or an arena is an example of a very live space, which doesn't have a lot of absorption in it, and it might sound something like this.
Many factors influence speech intelligibility.
While what we typically want in an office space sounds something more like this.
Many factors influence speech intelligibility.
That lower reverberation time that we get in the office is what happens with the effective application of absorption or absorptive materials on the surfaces and finishes of that room, and what we typically seek in a commercial space. Without that, you have the circumstance like you heard in the gymnasium, where the speech overlaps with all of the echoes that result from that speech, and the speech sounds quickly become unintelligible.
So, Jim, materiality is one of the things we look to as designers in order to absorb sound or reduce reverberation. So, for example, using a wall covering instead of a hard surface on your wall panels will allow them to better absorb and reduce noise within that space, but not necessarily impact sound transmission from one space to the next. So you'll see a lot of this reflected in the use of fabric wall coverings and PET surfaces, which allow for better absorption. Here you can see a freestanding and pod solutions, which represent how our products can interact with the built-in environment and impact acoustics across an open floor plate. These can easily be placed where problem areas exist and have been identified on your floor plan, and you can also reconfigure or completely relocate them in the future. So blocking is our next tool.
Sure. Thanks, Lori. Blocking is simply the way to describe what happens when a barrier is placed in the sound travel path. In offices, the barrier is typically a wall, a ceiling, maybe a floor ceiling assembly. It can also include the effect of office furniture and partitions in that space, although perhaps to a lower degree of performance. Now, remember that we said absorption works within a room and it relates to room acoustics? Blocking is a property that works between rooms, and so it relates to something we call building acoustics. Both of these are related, but it helps to keep in mind that A, or absorption, works within a room, and B, works between rooms. There are several ratings that describe blocking performance in buildings, depending on the application and the type of construction. Some of the most relevant to offices are the ones shown here. Things like noise isolation class, sound transmission class, or ceiling attenuation class. Of these, STC and CAC, or sound transmission class and ceiling attenuation class, are both lab ratings. Lab ratings are useful because they evaluate the performance of a single construction element in isolation from all the other elements. But it's important to understand that this is an idealized test in an ideal environment. There are some things to keep in mind. So most important is that there's a threshold of perception that's about equal to 2 STC points. Put another way, two similar products with ratings that are only 1 point apart are going to sound the same. Our human ears are just not as sensitive as our measuring equipment. So differences of less than 2 points are imperceptible to human hearing. But it's also true that the measurement repeatability itself is about 2 points. That means on any given day and at any given lab, the same wall might vary within about a 1 to 2 point range in terms of the rating that it gets in a test. So the important thing to keep in mind is that these tests are idealized. They don't include the effects of all the other elements of construction in a typical installation. So they're good for comparison, or, as you might have heard, your mileage may vary in an actual installation. In the field, however, sound travels through all available transmission paths. The weakest path, or the path with the weakest barrier performance, is the one that will control the overall performance. And that path might not be the wall. It could be the ceiling. It could be the air handling system, such as the vents you see in the ceiling in this photo. Sometimes it's leaks between different construction products from different manufacturers, each of which perform well on their own in the ideal environment of the lab, but may not be fully integrated in the way they're installed together in the construction site. Remember that the blocking ratings are obtained in a lab. The real world, the actual performance will be lower, and so it's given a different name. ASTC is the apparent STC. Apparent because it's not necessarily obvious how the sound is transmitting, but it's a number that represents the performance of the construction without regard to room sizes. But the room sizes are also a significant factor here, including the absorption of those rooms. So the actual measure of what people experience is different still. And that's closer to what we call the NIC, or the noise isolation class. This is calculated the same way, but it encompasses the full effect of the room performance. So it's actually what people hear, not the STC rating of the wall. To put it another way, STC is what you've paid for. NIC is what you get. Now, moving on to C. C describes the effect of the background sound and how it covers the attenuated speech sounds. This is important in the way we actually hear everything. We hear sounds that are louder than the background sound. The background sound being the sound that exists without any human activity in the space. We have an entire CEU at Haworth on this topic, and you might find that interesting. So you can contact your dealer or sales rep if you're interested. But for today, we'll just leave it at the basics. We use the covering effect of controlled background sound to ensure the right level of privacy or intelligibility of speech in the right place when we want it, by measuring something called the signal-to-noise ratio. In open plan space, we use absorption, often on the ceiling, but it can be anywhere, to reduce sound over distances and minimize reflections. And then we use the covering effect of background sound to further reduce the distance in which someone can be overheard and understood. In closed rooms, this is the model. We use blocking first to reduce the sound level over a short distance. Then we can use absorption to further reduce the sound level in the receiving space, but its effect is much more with respect to managing the reverberation and the comfort of the rooms than it is with respect to the privacy. And it's important still that we ensure the covering effect of the background level is adequate for privacy. We don't want to leave the covering effect to chance any more than we want to leave the blocking performance to chance if we're chasing after privacy or intelligibility. Now, I need to make a special comment about a new product category, or relatively new product category called pods. Pods are special in that they have all of these elements. So we actually use all the same tools. We block the sound with the pod construction itself. We use absorption on the inside to manage the reverberation in a very small space and ensure comfort. And we use the covering effect via the ventilation fan to further cover incoming speech sounds. But the obvious advantage of pods is that all of these elements have been engineered together to work as a unit. So in this single unique case, the component measurements of NRC, STC, or NIC don't make any sense anymore. To measure the STC of the door, we'd have to literally take the door off the pod and measure it in isolation. To measure the NRC of the interior finishes, we could do that, but it really wouldn't give you any useful information. So, for this reason, we have a unique test method that has been developed specifically for pods. It's a method called the speech level reduction, or the DSA. It's defined by a new ISO standard, 23351, which describes a test method which essentially has a pod being built around a loudspeaker and measuring the loudspeaker output both with and without the pod in place. The difference, after some math, is a single number rating that represents the reduction in the sound power of a talker due to the pod. Like STC, the numbers provide a finer resolution than our ears can really appreciate. So this metric has been further expressed in the form of letter grades that you see here on the slide. Back to you, Lori.
So when we're talking about design and control, we talked about things that we can and cannot control. Again, these are the things we can't control. When we're looking at design, we have the opportunity to control distance, the construction, the absorption, as well as background sound and visual information. There's another way to control, and that's through policy. So enforcing employee norms and through behavior coaching and some corporate policy. So absorption is most effective in open spaces to help bring reverberation down across an open space. Again, back to these floor plans that we've seen before. How are we able to apply these different variables and design tools? Blocking is typically most effective between adjacent rooms and use types, such as offices, conference rooms, and then the corridors that separate them from the other open areas between them. And coverage is effective throughout the floor plate. So we know that speech privacy and acoustics is an important consideration for designers and customers, and we have several product lines within the Haworth portfolio to accommodate varying degrees of speech privacy as well as visual privacy, and we're going to dig into that next. So I'm going to take a few minutes to walk through Haworth's acoustic information for our products, and we have several wall products along with our sub-architectural and freestanding booths. We talk a lot about scalable acoustics and getting the best performance qualities needed for the individual situation at the best price point. So understanding the acoustic principles that follow will allow for a more balanced performance and cost-effective applications. So when you look at how these space needs for speech privacy and focused work, there are many different solutions. Movable walls and pods can both accommodate the various requirements at different scales. Haworth's demountable wall products offer space division and confidential speech privacy in a more fixed in place solution, whereas pods or booth products provide a similar level of privacy at a smaller scale and with much more flexibility. Both allow for easier change management and variable acoustical control exactly where it's needed. Our architectural wall systems have all the fluidity of furniture and the presence and permanence of walls. This is our enclosed product that you see here. It's our demountable wall solution. It offers the versatility to support your organization's diverse needs, but also support the acoustic control that they need. Our frameless demountable systems allow you to fine-tune both aesthetics and acoustics. Film can be added for visual privacy, and the ability to transition from single to double glazing in the same elevation without changing products allows a very curated approach to acoustical privacy and much more control over your budget while creating a very cohesive look. Scalable acoustics is such an important part of this discussion. It allows you to control acoustics precisely where it's needed, adding a second layer of glazing to boost the performance of the walls only in the zones where it's most necessary. And the solutions here represent how our products can interact with the built environment and impact acoustics across an open floor plate. Some manufacturers require more than 1, 2, or 3 systems to accommodate everything that the one system here is able to do. So our sub-architectural products that you see here, Pergola and Hush, have the ability to interrupt the open floor plan with places for people to collaborate outside of the traditional conference room. They also provide destinations for connection with a greater sense of privacy than normal open seating. So both of these, while freestanding and flexible, contribute to creating visual and audible speech privacy. Pergola is a sub-architectural beam and rail system. It can be easily designed to create so many different space types. This sub-architectural product is helpful in breaking up large open spaces without impacting or attaching to surrounding architecture. It can help reduce noise within open areas, creating rooms and alcoves where open furnishings would typically be used on their own. In our experience, these spaces then become a lot more functional and utilized as they create a sense of both privacy in acoustics and visual. So designing a large multifunctional space like this project room with adjacent breakout lounge areas offers people autonomy for where and how they do their best work, whether that's for focus or collaboration. Pergola can be easily designed to create so many space types. Lounge areas provide a space for restoration moments and chance for workers to step away for long work sessions. Central passageway that you can see shown here also helps influence circulation through a space, connecting the project room to the lounge areas, or by creating a front porch effect to the main activity space. So incorporating a variety of applications within just one pergola supports mode switching, so you can change scenery and fit the sound needs and the destination for the work that you're doing. And finally, Hush Office. It's single or multi-person pods that can be placed anywhere on your floor plate where private space or small collaboration rooms are needed. We even have these available on a quick ship program to give customers fast solutions to their acoustic challenges in the open floor plan. And with that, I'm going to pass it back to you, David.
Thanks, Jim and Lori, and thanks everyone for tuning into Haworth's webinar, Architectural Acoustics, Designing for Workplace Performance. I hope you all learned more about the importance of acoustics in the workplace. And if you are interested in diving even deeper into the importance of acoustics and designing for acoustic performance, let me remind you that Haworth has several resources available to download, including our Acoustic Design Guide, as Jim mentioned, the Speech Privacy CEU, and several research papers, specifically why we can't focus at work and designing for privacy, all of which can be found and downloaded on haworth.com. And thank you again.